So now we make our way in the energy problems when sometimes forces such as friction uh, eat up the energy or reduce the kinetic energy. And basically, we need to compute how that change happens, right? So here is a question which says, look at the figure, the speed of 8 kilogram mass. So the mass of this ball is given to be 8 kilograms. When the mass is at location A, its speed is 6 meter per second. Okay. And by the time it gets to position B, which is at 12 meter per second, estimate the frictional force opposing the motion. Okay. So now what's happening here is that mass starts with a 6 meter per second, and if it reaches B, what should be the speed if there is no friction? That's what first we'll calculate. And if that speed is going to be more than 12 meter per second, we know that the friction has eaten into the kinetic energy, or friction has reduced the kinetic energy, and that loss of kinetic energy, right? So the loss of kinetic energy is going to be equal to the work done by the friction, right? So the friction force and the work done. Now, to calculate the work done, we know that the friction will always act in the opposite direction from the Newton's law. So we have to take into account this much distance, right? So along this distance, the friction has done that work. So let's find that first. So this is D, and this is going to be equal to H divided by sine 30, okay? Because D is in this triangle, right? In this right angle triangle, basically. So H is given to be 12, and sine 30 is going to be 1 by 2. So this is 24 meters. So we are going to put this D, and this is our friction force doing the work over 24 meter, and that will be the loss of kinetic energy. So now in order to find this friction force, that is what it is asking us to find, the Fr is going to be the loss in kinetic energy divided by 24. Okay, so now this problem is partially solved, but we need to find how much is the loss in the kinetic energy. Okay, so how do we find that? So first we assume that there's no friction, right? So what will be the kinetic energy? And the ball arrives here, and then the final kinetic energy after the friction. Okay, so my loss in the kinetic energy is going to be the kinetic energy of the ball at B without friction, right? Minus kinetic energy of the ball at B where it arrives at B with friction. Okay, part B is pretty easy. Let's do this first. So my part B is going to be half into M, which is 8, into V square, which is 12 into 12. Okay, and this is going to be equal to, you can calculate that now. Yeah, so 8 into 6 into 12, that is 576 joules. Okay, now we need to find how much is the kinetic energy when the ball is arriving there without friction, right? So let's again start at location A. Ball has a velocity which is 6 meter per second, so it is starting with some kinetic energy. So there is a kinetic energy at A, right, which we can compute by half m into v square, and that is going to be half m into 8 into 6 into 6. Okay, so we can calculate that, and now the ball descends through a height h to arrive at B. So the energy at B, we can calculate the kinetic energy which we are interested in, half into m into my V final square. Okay, and this is the kinetic energy basically which the ball will have when it arrives here, right? So this is our kinetic energy without friction. Fine. And this kinetic energy without friction is going to be equal to energy at A, right? So with the law of energy conservation, total energy at A is going to be this sum, right, which is half into 8 into 6 square. I'm still not doing the maths, plus the potential energy at height h, right? That's going to be 8. Let's put the value of G is equal to 10, and h is equal to 12 meters. Okay, so this height is 12 meters, so we can put it there, right? So this is the total energy, right, at A, and that by virtue of energy conservation, where we have assumed there is no friction, will be also equal to kinetic energy at P, right? So this is also going to be equal to kinetic energy at P. Okay, so we can directly compute the kinetic energy at B without friction by solving this one. Okay, so let's do that. So this is going to be 4 into 36 plus 80 into 12, and let's compute that. 144, and then 960. Okay, to sum it up, that is 1104 joules. Okay, so it should have an energy of 1104 joule if there was no friction, but as we know, there's loss, right? So we are ending up with is 576, right? So how much is the loss of kinetic energy? It's going to be 1104 minus 576 joules, right? And that is going to be equal to 528 joules. Okay, 528 joules, and this loss is going to be equal to the work done by the force of friction. Okay, work done by the force of friction. Okay, so which we have already computed here when we started actually, right? This is going to be FR into 24. We are simply going to substitute there the force of friction is going to be 528 joules divided by the distance 24. 528 divided by 24 is going to give us 22 newtons. Okay, so that is the magnitude of friction force which we are looking for, right? So you see, these are very easy but interconnected ideas, right? So instead of just asking how much is the loss, they can ask for the friction force. So you have to then apply the work done formula to get to the force, right? So just be very clear about what you are doing, and then the solution becomes very, very simple. Otherwise, it will look very, very hard to you as well.